Hello everybody. Today we'll be continuing on with circles, moving on to some properties of circles. As usual, we'll do a quick review of our last lesson. We want to be able to find the arc length of a circle of 90 degrees with a radius of 2 meters. Remember, arc length does have to do with circumference. It's just like part of the circumference. So the visual representation would be we are finding this portion of their circumference right here. And so our equation for circumference, right, so circumference times a fraction, right, it's a fraction of the circumference. Remember, it's pi times diameter, that's what circumference is, and then we multiply by theta over 360, right? So we just plug in the pertinent information. We have pi, we need our diameter, our radius is 2, so we multiply that by 2 to get 4, and then our theta is 90 over 360. Simplify it, 4 in front of the pi, 90 over 360, we can divide that by 90, divide that by 90, we get 1 over 4, multiply this number and this number, 4 times 1 is 4, 1 times 4 is 4 pi, leaving us with 1 pi or pi. So your answer is either going to be pi meters or 3.14 meters. Either answer works. And you can do the same thing with sector area, right? So this is like finding the area of a slice of pizza. Instead of finding the area of the whole pizza, we're just finding the area of that one slice. And since it's based on area, we're just finding a fraction of the area. So we need to do pi r squared times that fraction. Pi times the radius 4 squared times 120 over 360. We go ahead and simplify the same way we did the last one. We can divide this by 120. We can divide this one by 120, and we get 1 over 3. Multiply the 16 times 1, giving us 16 over 3 pi. So your two answers can either be 16 over 3 pi meters squared, or you can plug this all into your calculator and get 16.7 meters squared. That is the area of that slice of pizza. And so some additional properties that we need to know are as follows. We'll go over one at a time. And here is our first property. We're going to go over the property, a visual of it, and how we set up an equation in relation to that. So our first property is the measure of the central angle is equal to the measure of the corresponding arc. The central angle is just the angle in the center, right here. And that's equal to the corresponding arc. The corresponding arc is just the arc that matches up with that angle, right? So this is going to be the same as this. They're just the same thing, right? So if these are the same, how we'd set up each of these equations are always just going to be blank equals blank. So in this case, we have the central angle, which is 60, which is going to be same as this arc, which is x. So our arc is 60 degrees. So our x is 60 degrees. That's one property that you'll be using, setting it up like this. And so here's another one. Vertical angles are congruent. And we've actually seen this before. This isn't just in circles, right? These are all lines. And so vertical angles are the ones that are across from each other, that share the same two lines, right? This 45 and x, they share both these lines. That's how you know that they are vertical. And vertical angles are congruent, and to show something is congruent, remember congruent means the same. To show something's the same, once again, we're doing blank equals blank. So we have 45 equals the other angle, x. So that x is 45 degrees. And you'll notice that these little symbols right here, that means congruent. So if you ever see these, that means they're going to be the same. Okay, and now here is our last one that you guys probably already know as well, that there are 360 degrees in a circle, and half of a circle is 180. So how we would set this one up is, since all of these add up to 360, we just, however many angles are on the inside, we have 1, 2, 3, blank plus blank plus blank equals 360, right? So that's how you would set this one up. We could go ahead and do that really quick. And then this one doesn't have an angle, but remember, half of a circle is 180. So this whole thing will be 180. So plus 180 equals 360. Add these two together. X plus 305 equals 360. Subtract 305 from both sides, and we get x equals 55 degrees. So this x is 55 degrees, no problem. And so we're going to do a couple examples using all three of these properties. So we have three examples and two each. And so for this first one, we want to find the arc of AB. So that's what this symbol means right here. This is the arc of AB. So we're trying to find this, right? So this is going to use the fact that central angle is equal to the corresponding arc, right? So that's going to be blank equals blank, and we just get the 45. That's going to equal x. We can call the AB x right here, and so that means the measure of angle arc AB is 45 degrees. So this is 45 degrees. They're just the same, right? It's just the same. Okay, and so we can apply that to this problem that's a little trickier. So now we have a 122, 58, and 2x plus 2. So it seems like there's a couple things we can do here, but we have to notice that they give us the arc here, 2x plus 2, and they give us this, 122. So since we're using the central angles equal to this, we're not even going to use the 58, actually. That's not necessary. We can cross that out. So we have to decide which ones are actually important for the problem. So now we set them blank equals blank. 122 equals 2x plus 2. And then for this one, we have to solve. So it's just an extra step. Minus 2 each side, 120, divide 2, and we get x equals 60. Moving right along. Awkward transition. La 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 la. Okay. Nobody cares, Mr. Holland. All right. So, example 2. We want to find the arc of BC. BC is going to be this arc right here. And so in order to find this arc, we have to find this angle first. Right? We notice, okay, well, what can we do here? We don't have, corresponding angles, right? We have a central angle, but we don't need this arc, we need this arc. So this uses vertical angles. This angle is right across from here. So since these are vertical, we make them equal to each other. So this is going to be 131 equals x. And so since this angle is 131, now we can say that the arc becomes 131 degrees also. So arc of BC is 131. Okay, and we can apply that to this problem as well. So this problem, we have all these blank angles, blank angle, this. So we have to notice, like, what's important, right? What parts do we have of this problem? Well, we notice that this right here is 3x minus 40, and this right here is 2x plus 5, and those happen to share the same lines. So these ones are going to be vertical, so we're going to use these angles and set them equal to each other. This 30 is not necessary. So we have set them equal. 3x minus 40 equals 2x plus 5. We solve for x, and we get 45. So our x is 45. Moving on to our last one. All right, so we want to find x for both of these. We notice that we have every angle in a circle. We have a central angle. We don't have any arcs here. We don't have any vertical angles. So what's left is the fact that all of these add to 360. So we just add them all up. Blank plus blank plus blank plus blank plus blank equals 360. 63 plus 90 plus x plus 179. We add them all up, and then we get that x equals 28 degrees. And we can apply the same thing for this one, a little more complicated. And there are actually two ways to set this up. Okay, the first way that you can set this up is you can notice that this 40 and this 2x, both of those are on a straight line. Remember, a straight line is 180 degrees. So one way you could set it up is do 40 plus 2x equals 180. Or you can notice that these are vertical. So that means if this is 2x, this is also 2x. And now we have every angle in a full circle, so we can add them all up and make it equal 360 as an alternative way of solving it. And either way, you solve both of them, and you will get x equals 70. Thank you for listening.